Okay, so our objective is to answer another problem that asked this question. So the problem is there a significant difference between the pre-test and post-test mean score of the students in mathematics? Or is there a significant difference between the competency of students in math before and after the intervention? So assuming that the intervention is using games in teaching mathematics. In objective form, this can also be to determine the effect of games in students' competencies. So let us consider the hypothesis testing. Step one is to state the HO and HA. If we will consider a two-tailed hypothesis testing, then our null hypothesis is there is no significant difference between the pre-test and post-test mean score of the students in math. And for the alternative, there is a significant difference. Let us set our level of significance into 0.01, or initially let us place 0.05, and then step 3, so let us identify what is the possible test for our data. So let's go to our data. So this is our data. So we have data for pre-test and post-test. So for the number of respondents, this is respondent 1, respondent 2, and until respondent 30. Or for the subject 1 to subject 30. What are the assumptions in using t-test for paired sample? So just like in other video, we emphasize that as much as possible, it is better to use parametric tests. And between the two identified tests, the t-test for paired sample and Wilcoxon signed rank test, the parametric test here is the t-test for paired samples. So let us consider if we satisfy the following requirements. So the purpose is to compare the dependent or paired sample. So this is correct because our data is pre-test and post-test. The students who took the pre-test is the same students who also took the post-test. And then our data is interval, so it is scores. And for in terms of the normality, the data is normal because the number of sample size is 30. So we will compare this 30 data pre-test with the 30 data in the post-test. So we can claim that the data is normally distributed. Then we are confident to say that with the preliminary test, the appropriate test for the data is t-test for paired sample. So step 4, let us generate the result. So let us use the Microsoft Excel to generate the result. So simply, we just need to click data, data analysis, and then locate your t-test for paired sample. So this is the t-test paired to sample for means. So just check that and select your data for pre-test. That is our variable 1. And then also select your data for post-test. That is the variable 2 range. And then click OK. So this is now the result of the t-test for to sample of means. So as we can see in this table, so we can just copy this, or let us first compute for the value of the standard deviation, SD. To compute for the standard deviation, this is just getting the square root. So it is equal to sine SQRT of our variance. And click OK. Then I'll select this. So this is one way of generating result of the test for paired sample. Or if not, you can also use the calculator. So we have here the list of calculators. So just go again to quick statistics calculator, and you can find there the list of this one. So this is the quick statistics calculator. You can find here the t-test for paired sample. So this it is t-test calculator for two independent means. So just check that and take me to the calculator. And then you can enter now treatment 1 and treatment 2, which corresponds now to the pre-test and the post-test scores. So just to show how to use the online calculator, so let me copy the data for pre-test and paste in the treatment. Also the data for the post-test and paste it in treatment number 2. Then after that, click calculate. So it will show you all the solutions, but what matters again, as mentioned also in other video, is the value of the t. So it is 4.9t and t value is 0.0003. So obviously this is also less than, aside from saying that it is significant at p is less than 0.05, it is also significant at 0.01 because this is also less than 0.01. So just to check, you can always click another p-value here, the 0.01, and then click calculate. So it will give you the same result, and you can report that it is also significant at p because it's less than 0.01. So this means that we can actually change our level of significance into 1% or 0.01. So you can just copy the result here. So let us compare the difference between the generated data. So this is the generated data using the Microsoft Excel and the online calculator. So the t-value here is 4.9. The t-value in this data is also 4.9. So the value here is negative simply because we deduct our variable 1 is 9, the pre-test, and variable 2 is the post-test. So what we let Microsoft Excel calculate is variable 1 minus variable 2. That's why it's negative 4.9. While using the online calculator, it is post-test minus pre-test. That's why the value of p is positive. But the value of p-value doesn't matter. It will not, of course, change. So we have here the value of p, which is equal to less than 0.01, and also for the value of our p-value here, it's not also affected. And you might be confused with letter E here. So this just means that you have to move your decimal places into 5 units going to left. So it's 0, it's actually equal to 0.00003. So 1, 2, 3, 4, 5. This is equal to this value. So if you select this, you can also find for the equivalent value here. So it is the same. So after copying the result, so the result is that it is significant. So we are rejecting our HO. And then, so what's the decision? The decision is to reject HO. And step 6 is the interpretation. All we need to do is to edit our table and give the interpretation. And this is the interpretation. So just copy the value of the mean, computed standard deviation, our t-value, degree of freedom. The degree of freedom is also here, 29. So it's 30 less to 1. And this is the interpretation. So as shown in the table, the competency of the students after the intervention was higher than the competency before. So you can reflect the values of mean and standard deviation. And then, moreover, the result shows that there was a significant difference between the pretest and post-test because p-value is less than 0.01. So I indicated here double asterisk and place also double asterisk in the table just to show that there is a significant difference. So this reveals that the competency of the students improve after they were given the intervention. So it also suggests that the gains as an intervention is effective in improving competency of the students in algebraic functions. So it's up to you what calculator will you use. Will you use Microsoft Excel or if you want to use the online calculator? So you will get the same result.